In example 1, we're asked to draw the following angles in standard position. Then state in which quadrant the terminal side lies. We're going to take a look at the first one here, A, that's 210 degrees. It's in the positive direction. I'll try to do this in some different colors. Hopefully this will make sense to you. So if we get our protractor out, we know that we need to go 180 degrees and then 30 more would make 210. So then we're going to go to the 30 and try to make the best mark here that we can. And then all we need to do is draw this terminal side. Remember, in standard position, that initial side always lies on the positive x-axis. So we'll line these guys up. Oops. Try to do this in pencil, as you're kind of seeing sometimes. If you don't hold the protractor just right, it'll kind of make a little slip up there. Unfortunately, pencil doesn't show up great for these videos, so I am stuck using a Sharpie. And those don't erase very well. But anyhow, this angle is right here. We want to indicate the direction of rotation, so we would usually just start here at the positive x-axis where the initial side is, and then follow along in that counterclockwise or positive direction. And you can label this as just, A here or 210 degrees. That would be fine, just some way to reference that you're doing the first one. So A, 210 degrees is right there, and then it says then state in which quadrant the terminal side lies. So remember here, just a little reminder, maybe you know this already, these are pretty handy, and they're drawn in Roman numerals here. So that'll be 1, 2, 3, and then 4, and you label the quadrants in the direction that you would draw a positive angle. Alright, so we need to state the quadrant where the terminal side lies. So this terminal side is definitely in quadrant 3. So we want to use our Roman numerals here. We just do Q3. For part B, we've got negative pi over 3. I'll use red for this one. A few different ways to do this. One way is to just change this into degrees. So pi over 3 in degrees, we'd multiply by 180 over pi, and you're going to be looking at 60 degrees, and keep in mind that it's negative. So one thing that you can do if you're using a protractor is to change that into your degrees, and then just utilize your protractor. You'll notice that there are no radians here. That'd be kind of cool if there was. Maybe there is one out there, I don't know. If you do know, let me know, shoot me an email. I think that'd be kind of a cool thing to have. And then we'll draw our angle measure right here. One thing also that you'll notice is that if we were to take this half down here and split it up into 3 equal parts, then that would be 1, 2, 3 would fit into pi. In other words, half of a rotation in radians is pi, and so if you want one of those parts, that's just pi over 3, and we're down here in the negative direction. So we can make a little mark there, and we can label this as negative pi over 3. So a variety of ways to think about these radian measures, although sometimes it is nice to change it into degrees if you need to. For the next one, we've got, oops, almost made a mistake there, this is in quadrant 4. Got a little ahead myself, so I'll just go back and read the directions and make sure that you've answered the question fully, or else you'll get some points marked off, which is not good for anybody. Negative 180 degrees, we'll try this one maybe in blue. So negative 180 degrees, that would be that clockwise rotation, or beginning down first. And so we're going to carry this one all the way around 180 degrees, which would be halfway around. And you can see that we line up right here on one of the axes, and we're not really in a quadrant, so this is a special name for the angle, and this is called a quadrantal angle because it lies on one of the axes. It's kind of in the middle of a couple quadrants. And so one thing that we could use to describe this would be the negative x-axis. And I want you to know that. I want you to know that the negative x-axis, when I say that, it's over here and the positive is over there, which you kind of do know, I think, already. However, getting used to that terminology is a good idea. The next one's a little bit tougher. We've got 21 pi over 4. And 21 pi over 4 is going to be bigger than 360 degrees, or 1 full revolution. So there's a few different ways that you can attack this problem. One thing to do is just to change it into degrees and see what you get. So let's try that. We'll do a little calculator work here. So it's 21 pi times 180, and then we're going to divide that, and you got to do this in parentheses if you're going to do it like this. It's going to be 4 pi, and in this case, because there's a pi in the numerator, you really don't even need to mess around with it, but if you did type it in straight away, this is what it would look like. And if you hit enter there, you've got 945. So what we've got to do is we've got to come around to, let me get a new Sharpie here, we'll do orange for this one. And so this one's going to come around, it's positive, so it's going to come around 360. It's going to go around 360 more, that would be 720. So if we take away 720 from this one, we're left with 225 degrees. So after we've gone around 2 full revolutions, we're going to have to go another 225 degrees. So there's your 180 and there's your 45 to make 225. You can use a protractor for this one, although hopefully these boxes, if the boxes are squared up nicely, then what you can do is just hit the edges or the corners of each one of these, the intersection points of the grid lines, and that will give you a 45-degree angle. So I'm not sure if these do look like they are squares. If they're not squares, can't really do that. Alright, and so let's see here, forgot to label the other one, so we'll label that one 180 degrees. And the one in orange here, which we said was 945 degrees, same thing. That one we'll label here, and keep in mind you want to label it with the original angle. So if you're asked to plot or graph or draw 21 pi over 4, then just label it like that. So 21 pi over 4, that's going to be right here. As far as our rotations, this one's going to be kind of crazy. We're going to start off with 1 revolution, 2 revolutions, and then all the way around to 21 pi over 4, another 225 degrees. So I hope you're not susceptible to hypnosis, or else this video might put you to sleep. So if you squawk like a chicken tomorrow in class, we'll know what's going on. That's really it for this particular example. Oh, and then the quadrant would be quadrant 3.